4.2 is mins and max. Okay. Now, you guys, as far as we're concerned, if they're talking about local and relative max and mins, they're never going to be at endpoints. Our textbook says that as well. However, I have learned that local max and mins can occur at endpoints. But as far as you're concerned, don't ever look for them at the endpoints. Okay, so local ones is you've got to be in a complete neighborhood. So you have to have, it's always in the interior. And like here, this has no max or min, right? Those are, endpoints aren't there. So if you say I'm going to pick this point right here, I can just take the one where there's a hole and average them two, and I can always find a bigger one. So I can't find a max. But they're not going to occur at endpoints. When you are looking for relative max min, you are looking for a neighborhood. So I might be looking in this neighborhood. And that's actually what they call it in math classes, neighborhoods. And so if you have a relative max here, f of c is bigger than all the other y values in that neighborhood. Maybe not altogether, because maybe it did something like this. All right, I'm out of space here. But this would be like a bigger one. So this is just a relative one, local one. It's like the Christmas lights during winter break. Because different people have different lights. So in my neighborhood, I have the best lights. So that's because I have the only lights. But there are other places where they have wonderful lights. Okay. Global max and mins, f of c is bigger than all the other f of x's on the interval. Like, let me even write neighborhood here. Okay, so the global ones, when they ask you for a max or min, and they don't say relative, then they want the global. The other big mistake that everybody makes is that they forget to give the y value. This is the value of the function. And you may not have a global max or min, but this is the y value. So make sure that you answer the question on the free response. Well, even on the multiple choice, they might give you two x coordinates and three y coordinates. So make sure you get the right one. Okay, so when you're looking for max mins, it's the y coordinate that they're looking for, unless they ask you for where does this occur. Okay, so extreme values. So we've got the maximum value, we've got the absolute max, absolute min, minimum value. That's the lowest point on the graph. So if it's the minimum, what's true about f of c is less than all the other y values in the neighborhood or in the interval, whichever. Extreme values, so if they ask you for extrema, that is the plural in Latin for extreme values, and you're looking for the max and minimum values of the function. They are the y values, again. Critical numbers are towards the bottom. We'll do the extreme values now. We will do that. But so if I go down here, the critical points, I call them CPs. That's when your derivative at that value is 0 or undefined. And you can have critical points for the first derivative. So if you have f prime and you want to find inflection points, remember inflection points? For the concavity changes. That's the second derivative. It's the derivative of this. So it's where f double prime is 0 or undefined. But a lot of students ignore the undefined ones. So if you just think of your critical points as both of those, and inflection points are the critical points of f prime. And f double prime must change sign. That's how you prove it. And you can read the book. All of this is in the book, and just hold it out. else do we have there? Well, let's go on. Ready? It's an important theorem, Fermat. Let's do Fermat's theorem, and we'll do the maximum existence theorem. Fermat's theorem says, and I've seen this on the multiple choice in a variety of ways, if the function has a local max or min, and if the derivative exists, the derivative must be 0. And we can prove that with an indirect proof. With an indirect proof, a proof by contradiction is assume f prime of c does not equal 0. I just thought of this. Now, how do you find critical points? Either f prime of c is 0 or undefined, right? So if we assume that our first derivative is not 0, then that means, sorry, f prime, I missed no word there, but that's okay, is undefined. But what were we given? It said f prime must exist. But f prime of c exists. Have you seen this proof by contradiction? Therefore, f prime of c must be 0. Either the derivative is 0 or it's undefined. You're going to say it's not 0. Then that means f prime is undefined. But guess what? That contradicts this statement right here. F prime of c exists. So my assumption must be wrong. Have you ever used that kind of reasoning with anybody? When people assume things? It's only, yeah, it's all assume is when you make these assumptions like this proof by contradiction, you can only have two possibilities. Well, you have to be able to rule out more, but generally speaking, you only have two possibilities. Either this is true or that's true. Assume the other thing is true, and you will get a contradiction from one of the givens or basic assumptions. Assumption must be false. Now, I've seen this on the exam, and actually it's almost word for word when they'll sit there and say f prime, or they might say f prime does not exist. What's another version of this? You have a local max, and f prime does not exist. Then what has to be true? Then they'll have all the choices. And one of the choices will be f prime equals 0. Is that true? No, that's false. Yeah, they might say in this f prime is not 0. There's a lot of ways to say it. In fact, I think that's what it was. They said you have a local max, and they said f prime is not 0. So what's the only thing that's true? Then f prime does not exist. Because it's one or the other. And I remember the problem. So that's Fermat's theorem. And then what do we have left? The closed interval method? That must be something out of the book. It's the extreme value theorem or the max min existence theorem. You will see this on the exam all the time. Okay, guys? When the object is furthest to the left, what are we looking for? Furthest to the left. It's a minimum. Furthest to the right is a maximum. So you're going to see that. Well, there's a whole bunch of stuff that you have to get out of this. You must have a continuous function on a closed interval. So when I see a continuous function, and they're always going to be continuous because you can't do derivatives if they're not continuous. And when I see the closed interval and I can read through the problem and I say, oh, it's a max or min, well, then I know I'm going to use this theorem. This is a guarantee. I like guarantees. If you have a continuous function on a closed interval, then you will have both an absolute maximum value and absolute minimum. Okay, that's the first thing. I know they exist. Where do you find them? Where? Where are you going to look? These are the candidates. These are the possible places you will get a maximum in. The endpoints are possible, and then these are called the critical points, which we just talked about, where the derivative is 0 or where the derivative is undefined. So the only calculus I'm going to do is taking the derivative, and that's it. How do I know which one of these gives me the maximum? These are the candidates. I've got A, B, and C now for my candidates. How do I know which is the maximum value? Just evaluate it in the function. Don't make it hard. Just evaluate the function at each critical point. Right here. How do we find them? We evaluate f of x, not f prime of x, at each critical point. So you'd have to find f of c. Those are your critical points. Close like that. F of a and f of b. And you'll see which one the maximum is. It's whatever has the maximum value. Okay, is that okay? Hmm? Critical point where the derivative is 0 or undefined. That on the bottom. Let me write it one more time because it's so important. A critical point for f is where f prime is equal to 0 or undefined. Okay? And that's it on 4-2.